Extrema occur where a function changes direction. These are the peaks and valleys on a graph. We find them by locating where the first derivative equals 0 or doesn't exist. But how do we know if we've found a maximum or minimum? That's where the second derivative comes in. If the second derivative is positive at a critical point, the graph curves upward, giving us a minimum. If it's negative, the graph curves downward for a maximum. And if it's 0, the graph will have an inflection point. Note that inflection points aren't considered extrema, even if the first derivative is 0. Let's see this in action with the polynomial f of x equals x to the 5th minus 4x cubed. Taking the first derivative and setting it to 0 gives us critical points at x equals negative 0, square root of 12 over 5, and negative square root of 12 over 5. Checking the second derivative at these points reveals a maximum at x equals negative square root of 12 over 5 and a minimum at x equals square root of 12 over 5, while at x equals 0, we have an inflection point. This happens because the second derivative also equals 0 at x equals 0, and the function's concavity changes there. We can also find additional inflection points by setting the second derivative equals 0, which are x equals plus minus square root of 3 over 2,